We want to demonstrate practical, the way it should be done. Great scientists, engineers, young doctors, surveyors, architects. This evening we want to examine 2021 NECO trial questions. We are going to start from question number 1. This is the diagram of question number 1. This is retort stand, this one. This is spiral spring. This is spiral spring. This is mass. This is gravity scale. This is gravity scale, 100 centimeter long. You are provided with retort stand, split cork, spiral spring, mass hanger, weighing 50 grams, 420 grams slotted masses. Slotted masses, stopwatch. This is stopwatch, and 1 meter rule. This 1 meter rule. Arrange the equipment as shown in the diagram above. This is the diagram. This is the physical representation of the diagram. Suspend the given spiral spring on the retort stand. Spiral spring has been suspended already. Is there? It is suspend the given spiral spring on the retort stand. The position HO of the pointer on the spring is noted on the gravity scale. Record it. 3. Suspend a mass M is equal to 50 grams at the free end of the spring. Read and record the new position H. Set the body into vertical oscillation. Read and record the time T for 20 oscillations. For 20 oscillations. 4. Evaluate E is equal to H1 minus HO, T, find period T and T squared. Number 7. Repeat the procedure for 70 gram, 90 gram, 110 gram, 130 gram, and 150 gram masses. Evaluate extension E, time of oscillations, lowercase t, period, uppercase T, and T squared. Number 8. Tabulate your readings. 9. Plot a graph of M, that is mass, against E, extension. 10. Determine the slope S of the graph. 11. State 2 precautions taken to obtain accurate results. 12. Evaluate K is equal to 4 pi square over X, where S is the calculated slope. Bracket open, pi is equal to 22 over 7, bracket close. B1. State 5 systems that can be made to perform simple harmonic motion. B2. The period of a loaded spiral spring is 4 seconds and its amplitude of oscillation is 10 centimeters. Find the maximum speed of the motion. Pi is equal to 3.142. Now, you want to follow the procedure. We are directed to hang the spiral spring. This is the spiral spring. It has been hanged. Then we are directed to record the length of this spiral spring where it is high. If you look at this point, this is 17. The lowest pointer is 17 down. When you look at the top here, it's 27. Yes, 27. When you subtract 17 from 27, you have HO to be 10.0 centimeter. 10.0 centimeter. HO is 10.2 centimeter. E is equal to H1 minus HO. Now, we've been able to get our HO, that is 10.0 centimeter. Then we are directed to hang 50 gram. This is mass 50 gram. You hang it. When you hang it, the spiral spring extends down to 14. So we are going to subtract 14 from 27. We are going to get 14 from 27. That's 13. For mass of 50 gram, extension is 13.00. Now, after that, we are directed to displace this mass together with the spring gently. You extend it to 2 centimeters down. Then you release it. At the point you release it, you press the stopwatch. Then you allow it to oscillate for 20 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the time for 20 oscillation is 15. So we record it T1 15.00. T2, we repeat it again. We press the stopwatch back, then we repeat it. We repeat it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This one is 16. This is 16.00. 16.00. Now, the next one, we are going to add 20 gram. The next one is 70 gram. Yes. The next one is 70 gram. We had 20 to 70 to 50 to get 70. Then we get the extension. Extension of 70 gram is this is 12. This is 12. 12. 27 minus 12 will give us 15. 15.00. Now, we now displace it gently to get the time for 20 oscillation. So I want to displace it. You extend it to 2 centimeters down before you displace it. Just gentle displacement. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation of 70 gram is 18. 18.00. So we are going to repeat it to get to. You press the stopwatch to return back. We are going to extend it down by 2 centimeters before we release it. That is it. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation for the second one is 20. Now, the next one is 90 grams. We are going to add 20 grams to 70. This is it. The extension now is 11. You subtract 11 from 27. That is 16.00. 16.00. So let's displace it gently and get the value and the time for 20 oscillation. You extend it to 2 centimeters down before you release it. You release it gently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is 20 seconds. Then you repeat it. You press this button to return it back. You extend it down by 2 centimeters. At the same time, when you release it, you press the button at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is also 20. Now, the next one is 110. We add 20 grams to 90 grams. When you add 20 to 90 grams, the extension is 10. So you subtract 10 from 27. That's 17.00. That's 17.00. So we displace it gently. You extend it down by 2 centimeters. At the point of displacement, you press the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for oscillation for this is 21 seconds. 21 seconds. Let us repeat it once again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation for that one is also 21. So we are going to add 20 grams to it to make it 130 grams. 130 grams. So let's check the extension. Extension for this is 9. 9. We remove 9 from 27. That is 18. 18.00. Now let's displace it. You just extend it down by 2 centimeters before you release it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation for that is 25 seconds. Now, let us repeat it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is 25 seconds. Now we are going to add to get 150, we are going to remove 40. This is 50, 50, 100, 140, 100, 50, 100, 140. This is 140. Okay. We have 50, 50 grams. Let me use 50, 50 grams. This is 50 grams in 3 places. So I want to hand it. When I hand it, the extension is 8. The extension is 8. 27 minus 8 equals 19. So let's displace it. You extend it down by 2 centimeters before you displace it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, I did not return it back. We are going to start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The time for 20 oscillation is 26. Let's repeat it. Let's repeat it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Time is also 26. Now, to get our extension, you remove H naught from this H1 to H2, 3, 4, 5. So the first one is 30 minus 10. That is 3.00. 3.00. The next one is 15 minus 10. That is 5.00. The next one is 16 minus 10. That is 6.00. The next one is 17 minus 10. 7.00. The next one is 18 minus 10. 8.00. The next one is 19 minus 10. 9.00. To get the average TA, you add T1 plus T2 and divide it by 2. 15 plus 16 is 31. 31 divided by 2 is equal to 15.5. 18 plus 20 is 38. 38 divided by 2, 19. 20 plus 20 divided by 2, 20. 21 plus 21, 42 divided by 2, 21. 25 plus 25, 50 divided by 2, 25. 26 plus 26, 52 divided by 2, 26. To get our period, you divide TA by 20. 50.50 divided by 20 will give us 0.775. 0.775. 19 divided by 20 is equal to 0.903. 0.903. 20 divided by 20 is equal to 1.000. 21 divided by 20 is equal to 1.050. 25 divided by 20 is equal to 1.563. 26 divided by 20 is equal to, this is 0.950. Oh, sorry, this is 0.950. This is 1.00. 21 divided by 20, 1.050. 25 divided by 20, 1.250. 26 divided by 20, 1.330. 1.300. Now, to get t squared, we are going to square this column, uppercase T column. 0.75 times 0.75 will give us 0.601. 0.95 multiplied by 0.95 will give us 0.903. 1 times 1 will give us 1.000. 1.05 times 1.05 will give us 1.103. 1.25 times 1.25 will give us 1.563. 1.300 times 1.300 will give us 1.690. Now, let us plot the graph of mass against extension as directed by the question on number Number 9. Plot a graph of M, which is mass, against E, which is extension. We are directed to plot M against E. You are going to write the unit of M on the vertical axis against E on the horizontal axis. Now, if you look at the values of M, the minimum value is 50 grams and the maximum value is 150. Therefore, it will be reasonable to use a scale of 20 to represent 20 grams to represent 10 small square. So at the beginning here, the origin is 0. The next 10 small square is 20. The next one is 40, 60, 80, 100, 120, 140, 160, 180, 200, and so on and so forth. Now, for the extension, the minimum value of extension here is 3.00 and the maximum is 9.00. It will be reasonable here to use a scale of 1 centimeter to represent 10 small square. So the origin is 0, the next 10 small square is 1, the next one 2, 3, 4, 5, 6, 7, 8, 9, 10. So let us start the plotting. So the first one is 50 grams against 3 centimeters. This is 40 grams. This is 60. In between 40 and 60, we are going to have 50. So we are going to count 5 small squares. 1, 2, 3, 4, 5. This will be 50 against 30. This is 1, 2, 3. We are going to trace it down until when we get to 3 centimeters. Then followed by 70 grams. 70 grams against 5. This is 70 grams will be in between 60 and 80. So you are going to count 5 small squares. 1, 2, 3, 1, 2, 3, 4, 5. So we are going to trace it until when you get to 5. This is 5. This is centimeter, 5 centimeters. The next one is 90 grams against 6 centimeters. So 90 will be in between 80 and 100. 1, 2, 3, 4, 5. Then we trace it until when we get to 6. 6 is here. The next one is 110 against 7. This is 110 will be between 100 and 120. 1, 2, 3, 4, 5 against 7. This is 7 here. When you check below, you see 7. The next one is 130 against 8. This is 130 will be in between 120 and 140. 1, 2, 3, 4, 5 against 8. And last but not the least, 150 against 9. This is 140, this is 160. So 150 will be in between 140 and 160. 1, 2, 3, 4, 5 against 9. So then we join everything together with this long plain ruler. We are going to get this. So we are going to get this graph, or we can even select this Let us select this. This will be reasonable. Let us select this one. It will cut 1, 2, 3, 4, 5 points. So this one will be there. Now we finish plotting the graph. The next thing now is to calculate the slope. We draw a very large right angle triangle. Very large right angle triangle. This one will give us draw a right angle triangle. This is a big one. Your y2 will be here. Your y1 will be here. Your x1 will be here. Your x2 will be here. So we are going to use the formula y2 minus y1 over x2 minus x1. Our y2 is 150. 150. Our y1 is 50. If we trace this one here, we are going to get 50 here. Our x2 is 9. Our x1 is 4. 4. 150 minus 50, 100. 9 minus 4, 5. 100 divided by 5. That is 5 here to 20.0. So our slope is 20.00. If you like, you can use this unit and this unit. That will be gram per centimeter. If you don't put it there, if you don't put the unit there, nobody will penalize you for that. You are calculating the slope, just write down the numerical value. But if you can identify the unit, you are free to put it there. So the next one now is precautions. And you are directed to write precautions. The first one is I avoided parallax error in reading meter rule. Make use of meter rule. This is our meter rule. Make use of it. Then I noted and corrected zero error in stopwatch. This is stopwatch. Make use of stopwatch. So you noted and corrected zero error there. Next one, you are directed to find K, which is equal to pi all over 4 pi squared over s. So our 4 is 4, our pi is 3.142 squared time, divided by slope. The value of our slope is 20. This one will give us 4 times 3.142 times 3.142 will give us 9.872. 9.872 divided by 20. This one will give us 4 times 9.872 is 39.489 all over 20. This one, if you divide this one, you are going to get 39.489 divided by 20 is equal to 1.97. 1.974 or 1.974 approximately 45 approximately 1.98. That is our K. Then the next question, you are directed to name 5 systems that can be made to perform simple harmonic motion. These 5 systems are the motion of a pendulum bob, then the motion of an object, of a body hung from a spiral spring. Another one is beat of human heart. The fourth one is the motion of loaded test tube oscillating vertically in a liquid. And the fifth one is the motion of the balance wheel of an analog wrist watch. So these are the 5 systems that can be made to perform simple harmonic motion. The next question is you are directed to find the velocity of objects, maximum velocity of object performing simple harmonic motion. You are given time 4 seconds, amplitude of 10 centimeters, final, and the maximum speed is v. The formula for that is v is equal to omega a. And the formula for omega is 2 pi f. And our f is frequency. The time is 4 seconds. 1 over 4 is equal to 0.25. So our v will now be equal to omega, which is equal to 2 times 3.142 times 0.25 times a, our amplitude is 10. When you multiply this together, you are going to get 15.71 centimeter. 15.71 centimeter per second. At times, you may be directed to write the answer in a meter per second. You can convert this one to meter per second. 100 centimeter is equal to 1 meter. 1 centimeter will be 1 meter all over 100. 15.71 centimeter will give us 15.71 meter all over 100. So v in meter per second will now be equal to 0.157 meter per second.